Very privileged here to interview Chris Duran of Terrafugia, which is going to be explained to me. You need to explain the word first, if you'd be so kind.
Terrafugia is Latin for escape the earth. So it's a very appropriate name for our company that's producing flying cars.
Indeed. Now, I heard the presentation, so I've had a bit of a head start on this one. I'm right to say that you've got an unusual wing because you need the bottom flat because you fold the wing in. We're going to video that in a minute, I hope.
That's right. We're going to video the unfolding of the wing.
Yep.
So it's a unique kind of condition, right?
Yep.
Where in the configuration we're in now with the wings folded, it's a roadworthy automobile.
Indeed,
right? That
yes.
can operate
yes.
up to 70 miles an hour. It is certified to operate on U.S. highways.
Right.
And when we unfold the wings, it's a FAA certified light sport aircraft.
Okay, so, and the range, this is not your latest model, of course. You're moving very fast. You're doing vertical takeoff, is that right,
the next generation will be vertical takeoff. This is the first aircraft, the first product that we'll bring to market.
I see. Right, so you'll stay with this type.
That's right.
Because it'd be more energy efficient.
We can bring this to market quickly, and it's a proving ground for us for the next generation of aircraft.
Oh, right.
So we certainly intend to move on to urban mobility vehicles, to aircraft that have vertical takeoff and landing capabilities.
Yes.
But our first iteration is one that operates from airports.
Yes.
But you can garage at your home. Right? You can drive to the airport, unfold the wings and fly to your destination, fold the wings up and drive to your business meeting, right?
You've amazed this audience, this 3,500 delegates here. They all come to your stand.
And we've had quite a number of people visit us.
Absolutely marvelous, absolutely marvelous. So tell me about some of the technologies. You've obviously developed a number of different technologies. You have to, because a lot of things are not just available off the shelf. Can you tell me what sort of new technologies are in this?
Actually, our philosophy is one more of taking existing technologies and combining them in new ways. Right. But there are some things that are relatively new. In this situation, we're using a certified aircraft engine that powers the aircraft when it's flying, and it also produces energy for our electric drive system.
That's a Rotax energy.
That's right. It's a Rotax engine that's readily available. It's a 100 horsepower engine.
Okay.
But we have a hybrid electric system, right?
Yes.
And we use electric motors to drive the wheels for the ground vehicle.
So you have quite a large battery in as a hybrid.
It's actually not that very large, because we can continuously produce power from the gasoline motor.
Indeed, right.
And the motor is one that, in this condition, we want to be able to drive up to a regular gas station in the United States.
Yeah.
And we pump premium unleaded fuel into it, just like any other car.
So that's obviously a non-sulfur fuel, and it costs less.
That's right.
Yeah,
it's much less expensive than aviation gas.
Yeah.
Right?
Yeah. Okay. And I think one of the arguments that I heard in the presentation was that it's not really you're going to be flying out of Kennedy anytime soon.
No.
It's really the case that in America, but also other places, I've seen it in Mexico, a lot of airports, airstrips and so on.
In the U.S., there's more than 5,000 general aviation airports, right?
Yeah.
So any one of them capable of having us take off or land.
And they don't have an Uber. They don't have, a readily available aircraft to fly with.
If you look at the vast stretches in the Midwest and the west part of the United States, there are lots of locations where people have their own grass strip or their own dirt strip, right?
Yes.
So there are plenty of places, ranchers, for instance, who fly all the time, right?
And this could take off on grass?
Absolutely.
Interesting. And we're talking two-seater here, but you do have an ongoing roadmap. Four seats.
Yep.
Yes.
This aircraft is designed under the FAA Light Sport Aircraft regulations.
Yes.
And that requires 2 seats. It was a set of regulations developed for the home builders who wanted to expand into producing aircraft for the masses. Right? So the FAA created a new set of regulations. Simplified, self-certifying, an easy way for those people to come to market. So we've certified under that set of regulations. It also requires a certified pilot, but one that only requires half the amount of training as a normal pilot license, right? So in 20 hours, you can quickly get your sport pilot certificate, right, and be ready to fly one of these. So this is not really that fully autonomous aircraft. That's the next generation, right? that doesn't require a pilot or requires an untrained pilot, right?
Yeah.
This is the first step in that path.
Yeah, yeah. Yes, we've noticed, I mean, the first stage of electrification of aircraft seemed to us, in terms of full electrification, seemed to us to be really sailplanes. And
it's okay.
And the sailplanes are of limited use, presumably. Just, I mean, they have instead of using the string to pull them up there, they sometimes have had simple internal combustion engines.
Sure, power gliders have been around
but I mean,
for
that's
a long
very
time,
limited.
That's right.
Yes, yes.
And in this case, you know, a power glider is a wonderful machine. It's a heavier sailplane, so it has a little bit less range, but they're great because you don't need a tow plane, right? You don't need somebody else to help you to get up to altitude to soar. That's not really what we're looking for.
No.
For us, it's the ability to drive to and from the airport that you operate from.
Oh, absolutely,
right?
yes.
So it's a bit of a different situation for us. It's a dream that's been around in aviation since the 1920s.
Yes,
and a number of different companies along the way have tried to develop this kind of a product. They always started with a car that they tried to make fly.
Yes.
And we've gone the other way. We've started with an airplane design, and we've turned it into an automobile as well, right? So our founder likes to call it a roadable aircraft rather than a flying car.
Well, right, okay. But I think it seems to me that another thing that's, if not unique, very unusual in your case is that you're the exact opposite of taking a sailplane and changing the motor. You are putting an enormous amount of effort into safety. You seem to have done an enormous number of things. I mean, I'm not aware of other aircraft that can parachute down on an emergency basis.
There are aircraft out there that do that now, but
relatively non-stall.
We've also designed in the automotive safety aspects of the aircraft.
Yeah.
And I'm going to introduce you to Carl Dietrich.
Hello, Carl.
Who's our CTO and one of the founders of our company.
Yes.
And I think he'll be happy to explain in great detail the technical aspects of the transition.
Yes, good. Okay, Carl. Well, we've got the background, and I think we've got the message that a bit like By Aerospace, who are talking here shortly, they've not taken a sailplane. They've started from scratch, and it's from the ground up an aircraft. In that case, pure electric, conventional aircraft. It's complementary to yours. It's not, I think, competitive.
Correct.
But in your case, you seem to have really gone from the ground up, and we'd got to the point of saying that it seems that you have unusually put enormous effort into safety. Can you tell us a bit more about that?
Sure, yeah. Well, there are a very large number of both physical and what I would call psychological safety systems embedded into the design of the transition, because the transition is still controlled by a pilot. And by far the largest source of aviation fatalities are caused by the pilot. So the more we can help he or she make safe decisions, the safer a product we will have in the end. So first, I'll go through some of the technical, physical safety features.
Yes.
So as Chris mentioned to you, we do have a full aircraft parachute, and that's always a last resort. But beyond that, we use a very, very safe, well-proven, certified aircraft engine that's certified to run on automotive gases, the Rotax 912 IS Sport. We also have a motor generator on the shaft of the engine.
Yes.
So in the event of an engine failure, something like that, we could potentially give you a little extended glide range with this engine. In addition, one of the unique capabilities that gives you is if you're operating out of a high density altitude airport, you can kick in a little bit of extra power, 20% extra power, to climb out if you're not achieving your desired climb rate. So it's a very, very nice safety feature to have on board the aircraft that a pilot can implement as needed. Just being able to kick in some extra power is incredibly valuable.
I've heard that's an issue with helicopters. When helicopters crash, it's you lose control completely. So if you had an auxiliary pure electric drivetrain that couldn't hold the helicopter up, but it would give you a little measure of control as you were coming to Earth, that's very important. And is that what you're doing in a somewhat similar way? You're getting a little more control that you wouldn't have otherwise in a disaster scenario?
You could think about it that way. It's extending the glide. So even if you had a complete failure of all power systems on board the transition, you could still control it and fly it safely down to a gliding landing.
Right.
So that's a safety feature right there that most people don't appreciate about any fixed wing aircraft. Right. So it's a very nice thing to have. in any general aviation aircraft, but with our hybrid electric system, we can give an extra power boost and extend that glide range quite a bit farther than you would otherwise be able to achieve.
But you've got interesting aerodynamics as well,
we do.
Yes,
we do have some very interesting aerodynamic features. One of those features is that the design of the rear end of the vehicle as it goes into the propeller, as the air flows into the propeller, in general, if you were at a high angle of attack, so the aircraft is at a large angle relative to the free stream air.
Gotcha.
That's when a vehicle would normally stall. So the airflow would separate from the wing and the wing would lose lift.
Yes.
And this is involved in one of the leading causes of fatal aircraft accidents that drives loss of control.
Right.
Stall at low altitude, which then you lose control. The transition we've designed so that the airflow separates near the root of the wing first, and we maintain very good flow over the outboard section.
We saw that in the presentation. The telltales were going mental here.
Right,
and
they were very smooth. And this is where you control the roll of the aircraft. And
has that been done before?
Yes, there are other aircraft that do that type of thing as well, but it's a very important safety feature that allows you to control the aircraft while you're fully stalled. The other very neat thing about this design is that because we have the propeller back here, when the air starts to separate at a stall, the airflow goes through the propeller and you change the loading on the engine and the propeller. So you hear the stall warning. Okay,
right.
And from a pilot, the psychology of a pilot, nothing gets the attention of a single-engine pilot more than their engine making some strange noise.
Of course.
Okay, because you rely on that engine, right? So this is a very effective stall warning system for the aircraft. In addition, once you do stall, the nose will bobble and things of that nature, but you won't break off to the side. So it's a very, very benign stall characteristic.
And I guess in addition, sorry to interrupt, but bird strike, you're less vulnerable than having the propeller here. Is that right?
A little. I would say the propeller is better protected, particularly when you're driving on on from road debris with the wings folded up, that sort of thing.
New problem.
Yes. Yeah, and also you could say bird strike as well. One of the other interesting safety features on the transition actually has to do with the fundamental design of the vehicle. So the center of gravity of the transition is about here, near the quarter cord of the wing. That allows us about a 50-50 weight distribution on the wheels, which is very good for handling on the road. But in addition to that, when you're flying, what this means is most aircraft have their main gear very close to their center of gravity to allow them to pitch the nose up very early to do soft field takeoffs and things of that nature. We can't do that in the transition. But what that means is that we're going to have a longer ground roll on takeoff. But by the time you get to the point where the vehicle lifts off, it just flies off the ground very simply, and you have quite a bit of extra energy, which translates to extra stall margin, right? So you're going to be, as soon as you're in the air, you have extra stall margin, extra energy. You're not as close to falling out of the sky again as you were in a normal aircraft on takeoff. In addition, because of the location of the rear wheels far after the center of gravity, your smoothest landing will be coming in with a little bit of extra power. So what that means is in all low altitude operations around your runway, you're flying with more stall margin because pilots want to make smooth landings, right? So on all the approach and landing, when you have the most common occurrence of stall spin and loss of control, you're operating at all phases of flight near the ground with higher stall margin than you would otherwise in a normal aircraft. So all of these, it's a connection between the physical and the psychological safety that we implement on this vehicle. In addition, with the four wheels all far away from the center of gravity of the vehicle, you come down in almost any configuration and it's very stable landing. So it's very, very hard to have an unsafe landing in this vehicle. It's just more robust than anything else that you have out there. So it's Sorry, go ahead.
No, not at all. I just want to get clear, you have this product, you are now in parallel working on vertical takeoff, but this product itself could have an extended life as it transitions to fuller hybrid, to pure electric, to extremely short takeoff and landing, or at least short takeoff and landing. You could have a whole roadmap. Have you got something like that, or is it in your mind that this is your first product, and then you're going to go 100% into vertical takeoff. Which is the route?
Well, this is our first product. There are, I'm sure, improvements that we will make on this vehicle. In fact, one of the things that I'm very interested in is incorporating more advanced avionics in the vehicle to allow us to do advanced flight planning, advanced route planning, that sort of thing that takes into account weather, that helps the pilot make safer decisions. That sort of thing. Really, this is all about lowering the barriers to entry, making it easier to fly, making it safer. Right now, flying a general aviation aircraft is safer than riding a motorcycle, but that's not saying much. It's not as safe as driving your car. It's not even as safe as riding a bicycle right now. With the transition, we believe that it will be possible to bring the level of safety to the point where we can say, look, flying this flying car is actually safer than riding a bicycle, statistically speaking, and potentially with increasing levels of autonomy that we can bring into the cockpit, we may be able to get it to the level of safety of an automobile today.
So you're thinking of going to four-seater?
Not in the transition. So right. Developing a physical airframe is a very big investment. It's a very big deal. So we're unlikely to change the physical characteristics of this vehicle. We are likely to increase the brains, as it were, making it easier to operate and safer to operate as time goes on. Already, as it is, just our launch product, we're expecting to be one of the safest aircraft that you can buy for personal flight.
Clearly. So,
have you flown on it?
I don't. 3 or 4 times, something like that. I mean, we have a professional test pilot who does most of the flying, but that's why, and we try to keep this vehicle in the air as much as possible with the professional test pilots. But I've very much enjoyed my time in the cockpit. Wonderful. It's a very stable aircraft. That's one of the other safety features. We designed it to have a rather heavy stick. This is a cruiser of an aircraft. This is not, a lot of little airplanes are designed to be really aerobatic or yank and bank kind of flying. This is all designed around encouraging safe operations. The weekend getaway vehicle, where you take it up. So we have a little bit of a heavier stick, feels more like a larger airplane than it is. So it really, from every aspect, from the physical safety to the psychological safety of the people who are going to be flying it, it's all about making it safer.
And more accessible, in that although you need a pilot's license, there is probably less training required.
That's correct. The vehicle's designed to fit inside the light sport aircraft category. To get a sport pilot certificate, there's a 20-hour training minimum, which is half the minimum time to get a traditional private pilot license.
It's a lot of money. I mean, a lot of the reason for some decline in interest in aviation is the sheer cost, isn't it?
The training package, actually, for people who are not pilots, we would include training with the purchase price of the vehicle. Typically, but if you were to go out and get sport pilot training today, it might be $3,500 to $5,000, depending upon how long it took. Most people complete sport pilot training about 35 hours.
Right. And do you expect to be selling this in 10 years' time in either a fuller hybrid and pure electric form? Do you see that roadmap, or are you going to wholeheartedly go into vertical takeoff?
Well, we are definitely going into vertical takeoff, but for this particular product, it really depends upon battery technology. Today, the battery technology is not there to make this all electric and as safe as it needs to be, meeting minimum range requirements and reserve requirements. In the future, as battery technology improves, we'll continue to reevaluate that. But there is a safety aspect also that comes from having more range. And with today's battery technology, unless you go to very high aspect ratio wings, more like a sailplane, it's very difficult to achieve minimum reserve requirements. Now, one of the other folks at the show, George By and By Aerospace, they have a very attractive, very high aspect ratio wing. Very, very efficient. Of course, the vehicle isn't designed to drive on the road too. But that's how you can do it in an initial launch product. And they're also targeting, the trainer market. So it's a little bit different.
I think he was saying he gets 30% extra range by putting solar on his vertical surfaces. Do you have any interest in that? For
us, our battery on board this is so small that it's unlike, we're very, very weight sensitive. So it really depends. It's something that we'll look at. It's something that we would certainly consider. We certainly have plenty of wing area. But really our goal is to start to change the way people think about personal flight.
Oh, absolutely, one step at a time.
Try to make it more practical, more safe. Put it in people's garages so that you see it driving on the road.
It's interesting to us because we're trying to look in ID TechX very much at the future trends. We've got Alta Devices here again who are exhibiting, that's a kilowatt per kilogram with gallium arsenide photovoltaics, and so you wouldn't worry about the weight of that, but the cost at the moment is appalling, but it's coming down.
Right now I can buy power cells that are 5 kilowatts per kilogram. So and that's extraordinary. But and they have decent cycle life at those specific powers. But I can't get the specific energy that I would want for it. So those are maybe 120 watt hours per kilogram. Many of these all-electric aircraft concepts that you read about in the news today are counting on getting up into the 300 to 400 watt hours per kilogram range. So it's hard to buy that stuff off the shelf. It's made in laboratories right now, but it's not quite there yet. So, obviously we're staying very closely attuned to what's happening in the industry, and as the battery technology develops, certainly it can enable new and exciting products, because if we can go all electric, there's a lot of potential there, assuming the cycle life of the battery is also sufficiently attractive to dramatically change the cost equation. But one of the interesting things is when you look at these all-electric vertical takeoff and landing concepts, with today's battery technology, you would have to, even if you could get the specific energy up to where some of these laboratory cells are, they don't have the cycle life. So you're going to have to replace the batteries very frequently, which means that it doesn't actually save money in the end.
I realize.
That's a big challenge. So that's where I'm hoping to see development, because if it's not commercially effective, it's not commercially competitive, it's going to have a very hard time, because on some level you have to get to the point where you need the minimum level of safety. And then you need to be competitive in the marketplace. So right now, it's not quite there.
Well, one last question, and this is another strange one. A number of people in aviation now with small aircraft, they go into a thermal like a glider does, the propeller goes backwards, charges the battery on the way down. And you have to go pretty steep, but you can charge the battery. And then when you're parked on the grass, you, in a windy day, the propeller goes backwards, charges the battery. Is that interesting to you? Is that sensible or not?
If you have it anyway, certainly. To do that sort of thermal soaring and to get a significant fraction of power. Again, I think you're talking something like a sailplane configuration, very high aspect ratio wing, which absolutely can work very well for that type of market, the sailplane type market. For a practical longer range transportation aircraft, it's a little bit harder, but I absolutely expect we'll start to see, because there's a lot of movement in this direction, we will start to see higher aspect ratio planforms, more efficient aircraft as time goes on. It's a very exciting space.
Wonderful. Well, next time we're going to interview you, I hope, about the vertical takeoff activity, which obviously can't go pure electric anytime soon, but no, it's wonderful, and I do hope over the coming years we're going to see all that progression, because what you've done is truly groundbreaking, absolutely awesome, and thank you very much for making our whole show come alive. Wonderful.
Well, thank you for having us. I appreciate it.